Associate Professor Dr. Kamarul Imran Musa, or Kim, K-I-M, as he is popularly known in Kubang Krian. Prof. Kim is an Associate Professor in Epidemiology and Statistics at the School of Medical Sciences in Kubang Krian. He is the head of the Department of Community Medicine at the School of Medical Sciences, and he leads several research projects, a very renowned, prolific researcher, as well as a writer. He is the PI of Newton Ungku Omar Fund, where his team collaborates with researchers from the London School of Hygiene and Tropical Medicine, a very renowned institution, to offer solutions to caregivers for stroke patients in Malaysia. Now, he's very impressive. He's published a lot, more than 130 articles indexed by Scopus, with a total citation of 36,267. I repeat that, 36,267. And he has an age index of 42. So very impressive. We are all very proud of him in Kubang Krian, from the School of Medical Sciences. He's one of our hero. And I think he's very fortunate that he has agreed to give this talk, integrating AI in pandemic preparedness and response. So, Prof. Kim, the floor is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin. Thank you, Prof. Zulfail Alwi, my colleague, my senior colleague, for chairing this session. Thank you very much, sir. Thanks, RCMO and Prof. Zanovia Lokman for inviting myself and Prof. Zahir, and also to Prof. Naraza Muhammad Yusuf from IPPT for organizing or for coordinating this initiative. So without further ado, I will go on to my talk, and the title of the talk is Integrating AI, Artificial Intelligence in Pandemic Preparedness and Response. So my name's Kamarul Imran Musa, but by all means, just call me Kim. Right. So I'm a medical epidemiologist and public health medicine specialist. I'm also the fellow of the American College of Epidemiology. I was a member of the technical working group on public health, find, test, trace, isolate, and support system for the Health and Sciences COVID-19 Advisory Group of Experts, EAG, Malaysia. So EAG was appointed by the Prime Minister, the previous Prime Minister, when we first, mitigating the effect of COVID-19. So for those who are not, know much about health campus kesihatan, so that's our medical school of Pusat Pengajian Sains Perubatan. That's our wonderful hospital, and I'm not sure. I just saved my presentation in a PDF format, which you can download from bit.ly/AI pandemics. bit.ly/AI pandemics. I'm not sure if you can download it now, because a few minutes ago I saved a new version, so hopefully you can download it. The scope of my talk is about artificial intelligence for those who are not quite understand what is artificial intelligence. AI in medical and health. So whenever I say AI, it refers to artificial intelligence. Some use cases in health and medicine, development process for AI, assessment of AI, some privacy and security of AI, and hopefully all are relevant to all disciplines of knowledge. Engineering, social science, art, public health, of course, genome, math and stats, computer science, lab-based, people, so on and so forth. I was reminded by Prof. Zanovia. Thank you for reminding me to, let us know that this call will be open to everyone, and AI is an example where multidisciplinary people can come out with a team, and do some wonderful inventions. There will be no quotes in my talk, and it is not a technical talk. So artificial intelligence for some means machine intelligence. So it is intelligence demonstrated by machine, but of course, it is different from natural intelligence, displayed by our brain, right? So it's not that, but we are trying to mimic what machine or what our brain can do using machines. That the intention is. If you look at some definitions, there is no one standard definitions of AI, unfortunately. So this I took from Oracle, and it says that AI means systems of machines that mimic human intelligence to perform tasks and can iteratively improve themselves based on the information they collect. So it is a system that can learn on their own and get better and better and more intelligent, whether they can be intelligent more than us humans. That's one thing we should be thinking about. All right. The other definition is AI is a field which combines computer science and robust data sets to enable problem solving. It also encompasses subfields of machine learning and deep learning, which are frequently mentioned in conjunction with artificial intelligence. This is a little bit focused. It talks about computer science, it talks about data sets, it talks about machine learning and deep learning. But I think personally, when we talk about AI, it is more than that. It is larger than that. That's what I think. However, this is, if you Google AI, you always see this, artificial intelligence as the whole whole thing. And inside artificial intelligence, you'll find another two subgroups, which is one, machine learning. Machine learning is a technique. Okay, it's a technique by which we code. We do coding and let or ask the computer to learn from data. So we have to bombard the computer with lots of data. More data, the better the computer learn from our data. And then the intention is not to use complex sets of different rules. That was long time ago. Now we are using machine learning with dumb data and use some machine learning algorithm. Let the computer learn from them, from the data, and make predictions. And there's a smaller group under machine learning, which is deep learning. I think you have heard about deep learning. It's actually a branch of machine learning, but you have multiple layers, perhaps more than 3 layers of artificial neural network. You train your model using large data sets and try to make your computer or your model make predictions, right? So if you look at the cartoon there, you see, without machine learning, it's just like, you're giving us a specific instruction. For example, do this, do this, do this, and do this, and then you'll get this. But with machine learning, you primarily feed lots of data. It can be, structured data. It can be unstructured data. It can be data with number, or it can be data with without numbers. Like your voice, your pictures, and then by some wonderful algorithms, you can make predictions. Okay. Don't be afraid of this. This is, some algorithms you'll find if you do machine learning. Of course, if you do machine learning, you can categorize machine learning into supervised machine learning or unsupervised machine learning to identify some kind of patterns, and also reinforcement learning. There are hundreds of algorithms in machine learning. You got deep learning, you got assemble method, for example, for random forest, boosting, Adaboost. You have also, of course, regression. Don't forget, you can use linear regression, logistic regression, and make it into a machine learning algorithm. You have decision tree, for example, classification and regression tree card. You can use Bayesian approach, for example, naive Bayesian. You got instance-based, for example, k-nearest neighbor, locally weighted learning. You also have a clustering algorithm, all under the umbrella of machine learning algorithm. So there are hundreds of machine learning algorithms, right? And if you remember, I mentioned about deep learning, which is a more computer intensive algorithm which use lots of computer power. You might need, graphical processing unit to run hundreds of thousands or millions of parameters. So this is, a deep learning algorithm. If you look there, you can see deep learning neural network. For example, if you have an image, in this case is the President George Washington, and then you feed the picture as input, and then the algorithm will run. It processes. You may have lots of layers, and at the end, when it gives you an output, it will tell you what is the probability that this is George Washington. Okay, so you can see that you can move from this image processing and until the end where the deep learning will come up with some kind of prediction. Right, now we go a little bit more specific to AI in medicine and health. Right, so we know that, okay, AI in AI you got machine learning, and under machine learning you got deep learning. Okay, so what I'm going to do with AI? All right, so AI in medicine and health, I have some use cases. For example, in Google team have worked with ophthalmologists. They have trained AI model by reviewing more than 100,000 de-identified retinal scans. Retinal scans are the scans of your eye. And from there, they have developed an AI-based application. They call it as automated retinal disease assessment. So by using this AI software, it cuts down the examinations of eye. It can be deployed very widely. So this tool help doctors to expand high-quality diabetic retinopathy screening programs in countries without enough eye specialists. I think that will, also relevant to Malaysia. So we can deploy this, through maybe mobile phone or mobile vans or whatever, and you can screen many patients or many people in a very short space of time. Another example is, you need pathologists to look at the slides, and it is not easy. Of course, pathologists will also make error. Junior pathologists will maybe read or make more errors compared to senior pathologists. So, but, by using AI, you can convert this and use computer visions to, predict what would be the disease if you give this or if you input this image to your AI software or AI tools. Okay, right, and that will cut time because it will just take maybe 0.001 seconds to come up with a probability of certain cancers. Whereas if you want a pathologist to look at the slide, you need to call them, okay, ask the pathologist if he's busy or not. It may take hours, or it may take days or weeks. There's another one, IBM Watson, which has been used in some of the private hospitals in Malaysia, where the oncologists, they will look at or they will key in the diagnosis of a disease, and the IBM Watson will look for the best treatment or the best possible treatment or management based on more than 300 medical journals. It just maybe using some kind of natural language processing or NLP, and that will come up with what will be the best, treatment plan for that patient. No, imagine you yourself had to read 300 medical journals. It will take years, right? And of course, in radiology, radiology is one discipline that is using lots of AI. And this is another one where you can read the images from chest X-ray or MRI, and then fit into the server, and then into your AI algorithm, and the algorithm will tell you, okay, what would be the probability of brain hemorrhage, what would be the probability of brain cancer in this patient in just 0.0000 maybe 1 seconds. If we look at AI in infectious diseases, okay, specifically, this is the motivation. So this is where I think everyone needs to look at your expertise and think, what can I contribute to AI, and who can I work with for AI? For example, one motivations for AI in pandemic response and preparedness is to forecast infectious disease dynamics. Okay, when can we forecast infectious disease or a pandemic or an epidemic? The question is not whether a pandemic will happen or not. The question is when another pandemic will happen, and which pandemic will happen. Okay, is it is it going to be another COVID-19, or is it going to be tuberculosis, who has been around us for many, many years, and now we have seen the trend of increasing number of tuberculosis. So remember, COVID-19 is not the only pandemic. TB is a pandemic, HIV is pandemic, and some other common diseases that kita lupa because kita were very focused on COVID-19. But there is also possibility of a new pandemic. Are we prepared for that? All right. And then, of course, like my friend Prof. Zahir mentioned about surveillance and outbreak detection. Can we have a machine that can, at real time or very quickly, alert us if there is a possible outbreak? Right. And, of course, real-time monitoring of adherence to public health recommendations. Are we using our mask properly? Are people using masks? Are they washing their hands? How can we measure this? All right. Nobody in Malaysia, I don't think we have a system or we have a tools up to now to measure or to quantify the practice of wearing masks, the practice of washing hand. All right. People say I wear masks, but are they wearing as recommended? Real-time detection, for example, like influenza-like illness, triage and timely diagnosis of infections, prognosis of illness and response to treatment. That is also one area that we can look at. How can we make, we can innovate something that can help in the prognosis of illness and response to treatment. And this whole thing, all these 1, 2, 3, 4, 5, 6 motivations are not or does not belong only to medical discipline. This needs tremendous collaborations from various disciplines: engineering, social science, art, genetic people, public health, and so on and so forth. Computer science, of course, math and statistics, definitely. So this is one example where a company has developed a germ watcher, a germ alert family, where it support the infection control specialists in detecting, tracking, and investigating infection in hospitalized patients. It can make predictions. Okay, it can make prediction. It is not a real-time dashboard. It is not just a dashboard. It's a smart system that tells us, okay, what will be the pattern of infections in the hospital. This is Blue Dots. Okay, Blue Dots is a SaaS software as a service, for enterprise risk management. So SaaS, okay, don't apa ni tersilap dengan SAS, statistical software. This is SaaS, software as a service. So it combines machine learning and human intelligence, to identify signals of emerging global bio threats. It can also look at the triage bio threats and empower organizations with data-driven insight and expert content. It was developed by epidemiologists, scientists, and physicians. So it has databases, it got dashboards. Of course, they have these machine learning models, and it fits. Where does that data come from? Data come from 300,000 plus articles a day. The machine or the algorithm scan each day the amount of articles they are screening. More than 35,000 sources and more than 65 languages. So I think definitely there's some kind of natural language processing expertise used in this global infectious disease intelligence or Blue Dots platform. This is Epitope Predikt by iBiologics. So it is an artificial intelligence software with deep learning algorithms. So it expedites and refines antibody discovery, diagnostic development, vaccine design, and immunogenicity mapping. So it uses supervised and unsupervised learning. Those are the components of machine learning using experimental data. And then it will tell us, okay, what would be the probability that of immunogenicity score. This Professor Fale is an expert in this. For example, if you got epitopes of this, and then this is the a high score for that epitopes. And Vigilant Gantry. Vigilant Gantry is a fully automatic contactless gantry system for temperature screening. I think we have seen this, many times. It was driven by artificial intelligence and deep learning, where it used thermal scanners and gantry system to improve the rate of contactless scanning. So there will be no bottlenecks. All right? So there won't be long queues. So it is easy to use. And it can be coupled with your existing thermal cameras or CCTV system. So it just, using your computer and a camera, it will, scan your temperature and also maybe connect with your travel history, so on and so forth. So this was developed by a company in Singapore. Another app is ResApp. It is a powerful platform for respiratory disease diagnosis and management. It does not require physical contact. Okay, what you need to do is you need to have a phone with high quality microphones, right? And then you just cough, and then by using machine learning algorithm, deep learning of course, it can detect, even for COVID-19, 92% correctly identified just by listening to the cough. Okay, so the input in this is not numerical data, is the sound of cough. Okay, how you cough, then it will come up with, okay, a croup not indicated, lower respiratory tract disease indicated, pneumonia indicated. So if you are coughing, you'd have to call your doctor or go to the clinic. You just download this app, cough, and then listen to what would be the possible diagnosis of your cough. All right. If it is something not serious, then maybe you can stay home. But if this is something that is serious, then you might want to go to and see your doctor as soon as possible. HIPAA AI. HIPAA AI also use a cough sound. So this is a field that the researchers claim a new field, acoustic epidemiology. Okay, acoustic epidemiology. So it detects abnormal spike of symptoms where it can indicate public health concerns. So when you cough, right, the application hears your cough, and then it will change to 3D image like this one, a spectrogram. So you have to work with audiologists for this, right? And then it listen to your pitch, it listen to your intensity, and then this has been trained using more than 270,000 sounds. So again, when we look at developing AI tools or software or apps, you got to have lots of data. That's one thing that Malaysia or researcher in Malaysia have to think about. Of course, when we look at the AI, you have to be concerned. This is, I think, where some of us, ethicists, social science, or data security engineers have to maybe can join as a team and look at the personal data, the ethics, and the black box issue in AI or machine learning or deep learning. Because in healthcare we need lots of personal data, and because of that there are concerns about responsible data management, your privacy, consent, security, ownership, and if something happen, if you cough using that ResApp, for example, and it comes back as, oh, something not serious, but after a month you still having the cough, and then you go to see a doctor, and your doctor say, my God, you got cancer. What would you do? Will you sue the company for making the wrong diagnosis? Right? So there is some of the things that you have to look at. Okay, what if the software or the apps were developed in other countries using data set from other countries, not from your population? Would that introduce bias to you when it is applied in our setting? So that's another thing that we have to look at. Ethics, what should be done? Tooling for interpretable AI, fighting digital bias. What would be the right regulations? What would be the IP protections, law? So all these are related to ethics by design. So if you have someone, and I think it is very, very important to have someone who are very ethics conscious when in a team that are trying to develop AI or machine learning or smart or apps or whatnot. And sometimes, or not sometimes, many times, operations of AI are often unclear, what we call as black box, because of the complexity of data and algorithms. So, that's one thing that we have to think about. How about some compliances and some standards? You have to look at the HIPAA compliance, all right? HIPAA requires access management to safeguard protected health information system. Access should be only granted for those that need it as their job function, right? When your data is processed, it passes through server. When it goes out from your organizations, does it undergo data encryption? How about de-identifying your data, right? Do you need patient permissions, so on and so forth? You also have FDA, Food and Drug, I forgot, FDA, 21 SCFR Part 11 compliances, right? For system validation, full data security, and of course, you got GDPR, right? Okay. Then of course, the concept of no peak, right? Now the issues of whether your apps should be governed by the government or should be governed by no one, right? So, for example, MySejahtera is owned by nobody knows, right? Is it the government or is it the company? I won't go into that, right? But the issues of no peak, okay? So we can have what we call as distributed deep learning methods, which allow multiple entities to train deep neural network. So without requiring data sharing or resource aggregation in one single place. So no peak is, I think, is a sensitive issue. I know that old people like ourselves or myself, doesn't care so much about this no peak. But for younger people, they care a lot about their data, about sharing their data. So this is where, for example, a distributed learning without raw data sharing, whether you need to have multiple remote databases or servers, or do you need to do all the computations on your mobile phone, all right? So this is, I think, an active area of research. again, again, ethics and AI, some two things that cannot be separated, right? How about transparency? How about safety of your tools or your apps, of your software, accountability, data management, solidarity, public good, MySejahtera, is it good for public or is it good for the company? Are you, you have to pay, lots of money for that, all right? Prevention of harm, respect for diversity, protection privacy, right? Are you happy if your country track your locations? You look at what's happening in China, what's happening in Korea. Korea has been using lots of AI, but at the same time, people are worried about the big boss concept. Big boss. They are looking at you, and knowing where you are, knowing what you do. Are you happy with that? So I think having team members, one or two people in your team that that are specialized or experts in this ethics is also very important. AI does fail, okay? Bad data sets, automated discriminations, and of course, human error. So I won't go to that, but AI is not all great. In fact, we had a phase before where we call it as AI winter kan. Dulu naik AI, and then suddenly nobody cares about AI, and that was AI winter. You want to look at policies that are related to AI. I have talked to one person who is writing or drawing policies for AI for the Ministry of Health. Unfortunately, according to her, at the moment there is no published guideline or policies for AI in health and medicine for Malaysia. So I've Googled and I found one that might be relevant to us, which is the Malaysia Digital Economy Blueprint, which shows that which in I think it's one of the page stated that research has shown that AI technology can increase GDP by up to 26% in the next decade. So I think if you can prove the benefit or the what the betterment of life, the improvement economy by your AI application or software, that would be in line with Malaysia Digital Economy Blueprint. Of course, later on when you think if you plan for publish your findings, especially for medical journal, you have to look at some of the checklists. So if you know or if you're aware of the checklist before you write your paper, then I think you can write a much better paper. So this is a tripod checklist. If you want to make prediction model, so they have checklist for prediction model development and validation. And another one is tripod checklist for prediction model validation. Medical journals always ask for this, all right? Whether you got good title, what the source of data, who are the participants, what are the outcomes, so on and so forth, all right? If you look at the team to develop AI, it is a job that have to be work together. You need data modelers, you need deep learning specialists, you need data engineers, you need software engineers, you need domain experts, of course, you need product designers, you need AI sociologists, ethicists, you need operation professionals, IT leaders, strategy executive, and business analysts too. Of course, mathematicians and statisticians to develop wonderful models, applied machine learning engineers, user experience, UX, graphic designers. So you need people from art to design a good, wonderful interface for users to use your apps. QA specialists, human resources leaders, lawyers too, all right? Lawyers too. Don't forget about lawyers, all right? Ethics of AI, something that we have to look at, social science in AI, mathematics for machine learning. You need mathematicians, you need math, you need marketing, CS professor, data analyst, you may need accountant, sales, so on and so forth. If you want to look at some of the FDA-approved medical devices based on AI and machine learning, you can go to that link. The FDA-approved machine learning enabled medical devices, or they call it as software as medical device, SAMD. Just now SaaS, software as a service. This is software as a medical device. So you can go there, but I cuba tengok, but no, nothing on pandemic. So it's half glass full kan, sama ada you see that as a constraint, or you see that as an opportunity to do some wonderful works. I think in conclusions, I would say that AI has been used in health and medicine for some years already, right? However, because of COVID-19, not COVID-10, all right, COVID-19, I did the slide last night, so apologies for that. AI powered pandemic preparedness and response against attention due to COVID-19. But again, pandemic is coming. Pandemic is around the corner. So we have to be prepared. So what motivates AI works in health and medicine? And AI requires a team with multidisciplinary expertise. Of course, there are major issues: data, expertise, subject matter expert, computations, deployment, lots of potentials, I would say, but beware of pitfalls, right? So I think that's my from me. Thank you very much. That's my email, my Twitter account, and my personal webpage. Thank you. Over to you, Professor Fale. Thank you.